Alright, we got sound? Okay, so, we didn't do any work yesterday. We assembled some shelves to clean up the basement. And somebody told me to get a webcam, so here's my webcam. Not in the style that most people would assume a webcam should be, but the thing is the most important thing here that I'm working on is the code. And anything else takes a back seat. So I want to be able to easily see the code I'm working on for documentation. And then also at the bottom right, I want to have something where I can easily see, what day it is, what video it is, and what things I'm currently working on in this bottom hand corner here in the screen. So there's not really much room for a camera, but I thought, we could make things interesting. Here's my setup. My setup is not good enough for r/battle stations, apparently. I can only wonder why. Probably because they have a, what do you call it? There's an unspoken rule that everything needs to be, I don't know, minimalistic and cleanly set up, I guess. Which are probably from, my code. You probably look at my code and you see my workstation, and you're probably like, wow, those are very different. Anyways, we have the bitpack put in the bitpack get functions right here. We kind of stub them out, and we want to use this code in these put and get functions down here. Where are you? So this put function and then the get function beneath it, we want to utilize these functions because we think that the problem is probably our bitpacking logic. From our tests where they're failing, we think the problem is probably bitpacking. So we're gonna open up this folder in Explorer to get at our project locations here, and we'll go back here. Let's run this build script, get our bearings here. Okay, so that's where we left off. That's good. So these should not actually be referenced anywhere yet. So if we kind of try to look at them, try to find them anywhere, we're not going to find them anywhere, right? They are not anywhere. This misspelling is for so this misspelling is intentional. The misspelling here is in case I I had this conflict where, is this the general and this is the specific, or is it the other way around? And I wasn't sure of how I wanted to think of it, but this is a private function, so therefore I thought it doesn't really belong to a class of put and get functions. It really is its own thing that has a specific put or get overload. That's how I was thinking of the function. But we can make a little note here that at control F help, so we know what that what that comment is there for. So yeah, if we see this, let's make an update here. 2021 0109 7:34 p.m. Vid IID 0081 and the time and 58. Okay, so the update is for so when I use an @ symbol on a comment, that means it's kind of a generic commentary, right? I'm trying to say something very concisely that I might want to say quite often. So when I say control F help, I'm trying to say, hey, I wrote this specifically in the source code so that if you use control F to search for something and you stumble upon this, it'll lead you to what you're actually looking for. And rather than keeping a big block comment of that verbose commentary, we want to keep just the shorthand little @ thing to kind of say, hey, this is what we're saying. Now, when I use a hashtag, usually when I'm using hashtags, it's a very specific case comment. It's not a exact. So @ is for a general case, and hashtags are usually for specific cases. So when you extract a very specific block comment to a very specific piece of code, you're going to put hashtags around the commentary stub, and if it is a more generic thing, then we want to put @ symbols around that stub that we leave behind. Okay, so somewhere we are testing this function here. So we need to find where that's being called in our kind of debug code, right? Or our unit test code, right? And I believe if we do something like put and then, I don't know, UTC put, maybe we can find it. Unit test code put. Put brush state. But is there just like a UTC put? Yeah, so this thing right here. So the main put test, right? And let's see how we organize this code. So we got these like paired unit tests, main get put tests. Okay, so we've kind of like pragmatic controls. Okay, so here's what we're gonna do. We can put this in. We could put the new code in a lot of places, but let's put it right before what it depends on. So if we're gonna make a category, I don't know if it's the best. I'm not gonna say it's the best category here. We're gonna call it depends on, because it's gonna be the bit shifting functions that the main code, the main get and put functions is depending on. If that makes sense. So it looks like we have. So we got way out of hand with how we put all these semicolons here. We got way too designy, but if that's how designy we want to be, let's keep it symmetrical. So this is the depends on section. We'll say, test the bit shifting logic used by AAC 2020, PAINT5D put, and AAC 2020, PAINT5D get. Because I think the reason tests and are failing is B. Okay, so a big commentary here. That's not how we want it. 1, 2, okay. And let's make a note of the video ID here. So and the time is and 58. Okay, cool. So in this section, we're going to test the bit shifting logic used by PAINT5D put and PAINT5D get, because we think that's the reason the test for the PAINT5D put and the PAINT5D get are failing, because the bit shifting logic is wrong. We extracted the bit shifting / packing logic into their own functions to help verify that is correct. So now we'll actually call those functions down here, right? So we can take these, just paste them here, and rename them. So it was like bit shift something or other. I forgot actually what it was called already. So let's hopefully we have kind of our bookmarks in places that make sense. We'll remove that. Let's not forget about that. Forget about that. Forget about that. Yeah, I don't care about... Yeah, so there's a whole bunch of bookmarks I need to remove. Oh yeah, so it should be up here. Okay, up here is what we need. Okay, cool. So bitpack put, bitpack get is what we called them. Okay. So bitpack, and I think I did bitpack like Campbell case, I believe. Like that. Alright, so bitpack put and bitpack get. So if we actually look for the token bitpack put, we should find it matching this function. Yep, and then over here, take a look at this. Same deal. Okay, cool. So now the next thing is, well, we actually have to create these functions. So where are we going to create these? Well, I think they should be directly above these functions that we're testing. That would kind of make sense. Or we really don't care about the order too much here because of all the forward declarations. So it might make more sense just to put it where it's easy to get at, right? So we might just want to say, you know, keep this thing here, added functions on date added 2021 109, right? So we could make a little label like this and just make sure that the label is the same on the top and bottom. So I don't really, right now it's kind of a mess. We got a lot of code in here and we don't really care too much about explicitly where this new code is, but we should probably just keep it close to here, right? So keep the new code close to here because we're going to want to reference it while we're writing it, right? So let's take these functions names and just stub out the names, right? So let's just say void, right? And then okay. Oh wait, hold on. Okay, make a little divider. And then, right, so it was put then get is the ordering we use, right? Because you can't get anything if nothing was put. That's the justification for trying to figure out which order these two functions should be in. That's what we've come up with. Okay, so now that we have these stubbed out, what we just want to do is, let's just say error and to do. I'm not going to make a complicated to do message here because we just need to get these stubbed in, right? So right here we want to define error as AAC 2020 PAINT5D halt, and then down here we want to undef that. Okay. So now that we have this kind of fleshed out here, We just want to give it a run and make sure it works. But before we do that, well, yeah, I'm not sure. Well, let's just go back up to this function call here and say, well, we need to, for this to even work, we're going to have to remove these errors here. We should probably figure this out as well. So let's kind of figure out what this bit packing logic needs to be, and then we're going to do some push-ups and whatnot, because we want to get 100 push-ups and crunches and all that stuff before we can eat any food. We want to start to get a better exercise regimen here. So that's what we're going to do. But yeah, so for the put and the get, we have down here, we have the actual bit packing logic somewhere, right? We have this, we have like this offset dex. Hold on, let's take some notes here. So the offset dex, CPU pixels, this variable UO8. The offset index is definitely an input here. Global component will be kind of calculated from here, but let's just take these things. So offset dex and CPU pix we need as input parameters, and the other thing we need is the tile value, right? Because when oslock is going to be calculated using the osdex, but then we need the tile value somewhere. Yeah, so tile value here. So we know we need the tile value. We need the CPU pixels, and we need the offset dex. And I'm pretty sure that we already kind of thought about what the signature of this needed to be, but I don't see I don't see it referenced in my documentation here. I know I probably thought about it. I definitely know I thought about this before I stopped coding last time, but I just don't remember exactly what order I wanted for these parameters. So let's take these. We know these are the parameters we want, but we don't know what the exact I don't know what the exact order of this all needs to be. So let's kind of look through. Let's get rid of that. We don't need that. Bitpack put, bitpack get. We know they're being called before the getters and putters that rely on them, so that's fine. We can remove these stamps. That's put in place. Okay, so oh, we already have it here. So the CPU. So the global component index, is that not already calculated using the osdex? Because I took these. I didn't take glowcom because I didn't think we needed it. So if we look at the put function and we look at where glowcom is that needed? So if you look at glowcom, well, global index, and there's this tx, ty. So it actually does use, we actually do need to include the global component index, right? Because from what we're looking at here, glowcom isn't just going to be calculated. We don't have everything we need here to calculate glowcom, right? Okay, cool. So we don't have enough to calculate glowcom. And so last time we decided that this was the order, and there's probably a general to specific aspect here. So we have the pixels that we're targeting, which should be these, the component index, the offset index, and the tile value. And this is the order that these three appear in this order within the source code, so that makes sense that that would be the general to specific ordering. The CPU pixels, you need glowcom in order to put it into the CPU pixels, right? Glowcom is an index accessor into here. So this is general, right, because it's the whole collection, and glowcom is specific because it takes a specific index and accesses it within here. So I figure that glowcom is kind of a specifier to this, and therefore this one here is more general than this one. That was the logic there. Okay, so now that we know that, let's take these signatures and just throw them in here, right? So that we have them for reference. And we can say, you know, they're void. They're void. You might also want to do like U08. You might want to keep track of what the types are here. Right? That is a bit... It could be a little bit... I don't know. It's a little bit, it's not quite enough room here. We could have inclusive range syntax here to keep that smaller. We could remove this namespace. If we do all of that, we can keep this kind of shorter. Right? So the idea is that I just want to keep it nice and terse here so that I have all the definitions here. So if I want to cut and paste this into some code, I can do so, right? So all the parameters should be in the same order, so we could actually just paste here. And then we got to remember that over here, this is also a pointer, because it's an output parameter. And instead of value to put, it's value to get, right? It's a get output parameter. Right, so we might want to notate that a little bit different, just to say, hey, this is an output parameter. So this is the value to put, this is the value to get, right? So these two functions are complementary. Okay, so now, oh, I see somebody has stopped by. So right now it's just test code. It's still not fun stuff. We think that the problem in one of our functions is that the bit shifting logic is off. And therefore we're going to take this put function and this get function that do some bit shifting logic, and we're going to extract that logic into these functions to hopefully be able to find the source of the problems. Okay, so now that we have the body of these functions, let's actually start extracting that logic. So at first we're not going to delete the logic straight out of here. We're going to just copy paste what we can. So okay, so this section literally says bit packing stuff, so that's nice because we might be able to just get away with just taking all of this stuff and just being like, hey, take that, copy it, right? So this is the put function, I believe. Yeah, this is the put function, so we can just paste this down here into the put section. And we could actually get rid of a level of indentation that we kind of did this, so maybe not. Actually, no, let's try to give ourselves some more room to work with here, now that we're in a new function, I think. Well, let me think about that. I would eventually like to re-inline this code. So maybe not. I'll think about it. So, what do you got here? We got the variables we're working with, glowcom, CPU pix. they're all accounted for here. We have this array dex and var UO8. So array dex. Do we need the array dex, or is that's used over here, right? So we don't need array dex as an output parameter. That's fine. So I think, yeah, just pasting this code makes it pretty much good to go, except for the CPU pixels is this thing here. So what we could do is we could do like we could hack this together a bit and just say assert that CPU pix equals this thing here. Alright, make sure that this is always true. Always true. Not. Hold on. That's not always true. If we're running the unit tests, then this isn't going to be true. So let's see. Do we have a flag for if we're doing unit tests? Can we? So we have a ran or running. So now would be a good time for a flag for saying that the tests are running. So we could do UO8 AAC 2020 PAINT5D unit test is running now. Right? And you know, if so this assertion is only valid if we're not unit testing, because if we're unit testing, we'll supply it a different array. Unit. Uh, 45. Good enough. Yeah, so this assertion right here, down here, it's only going to be valid when we are not unit testing, because when we're unit testing, we're going to put other things into this first parameter here, right? That's the whole reason this has this first parameter rather than having it hard-coded as this thing, is because of how we want to kind of test some of this bit shifting logic in isolation. With that said, we actually have to implement this now, so let's kind of look for where this is and set these flags appropriately. So is ran or is running, right? So it seems that we just set this to 1, and that was enough for our purposes earlier, but now we need to do this. We need to go is running now equals 1, and then down here, after the unit test is done, right, we're going to flag it as not running, right? So so if we do it like this, one of the problems is that we could have a mistake in our code eventually where if somebody tries to call this directly, it's not going to work out, right? It's going to crash because this flag will no longer be true, right? So so what we might want to do for that is, I don't know, So might want to make a note that if this assert fails when you think it should be passing, it might be because the unit test well, hold on. Rather than doing this, rather than making a big note about, hey, if this fails when it shouldn't, here's why, let's not do that. Let's actually fix the problem. So right here, this is a public unit test here, this PAINT5D unit test, and if we have this public function, then we have to allow it to be, called publicly. So these flags here, we kind of set them here to make it kind of easy to read. However, and why is this down here? Like, where are we here? Init. Okay. So I get why we put it here, so that we could easily see it, but it would be more proper for these flags to be in here. Now, I don't see it as a big performance impact to just be like, well, let's just go into this actual function and also wrap it around here. So the private function, we don't have to put the wrapper there, because private is like a know what you're doing kind of a thing when you call it. So we don't have to put the wrapper there, but we might want to also put this here and then here. Right. So a little bit of redundancy, right? Because this is right. So we could make a note here that these flags may be used before and in wrap yeah, so we can just put these flags should probably also indent it, right? Like if we want might want to create a section here and say, hey, this is the unit test flag section, so that we know where these comments are applied to. Okay. Alright, so we are going to use both of these flags in more places than they're needed. Really, if we're doing it completely properly, then we would just keep these flags inside of the body of the function rather than wrapping function calls with them. However, this is a private function, and private means, hey, know what you're doing before you call these. So it's perfectly acceptable to like wrap some state around these private functions here, right? And the public function, you're supposed to not have to know what you're doing when you call it, so therefore we're going to need to put these state variables around it if that's how it needs to be when we're running it. Now, and then over here, when we use it over here, the reason we're doing it here as well is just so that we don't have to go into this function definition to get an idea of how these flags actually need to be used, because right now we're wrapping it with this condition, so it'd be nice to actually kind of see these flags be set here, so that even though we're doing this set and unset within here as well, we don't need to know about that in order to properly understand the code, right? So it's kind of weird because if you see just these flags here, then you'll have a correct mental model of the execution, a correct enough mental model of the execution to make correct assumptions about the code, even though your mental model is not 100% correct, because these flags here are also used inside of this function. But a model is only as good as its ability to predict what's going on. So even though the model might not completely match reality, it's a good enough mental model to help you reason about the code. Okay, so now that we have this flag for is running now, we're able to do this little assert here to be like, hey, if the unit test is not running, then we're going to expect that CPU pix is always equal to this thing here, right? You know what? I'm going to do this. I'm going to say if not equal to. And just a little error message of what's supposed to happen here. Or we'll do something like that. Sure, why not? Just needs to be a unique enough message here. Okay, so this bit packing stuff here, we're gonna have to remove this though, this one here, because this all uppercase version is now no longer always correct, right? It depends on if we're unit testing or not. So we got to get rid of that, and then anywhere we see CPU pix, we just need to change this to the lowercase one. So CPU pix. Okay. The other thing is, well, do we want to keep these commentaries here? Right? These commentaries are kind of still valid, even though we've extracted the code, so I think we should keep that commentary. I think that's fine. Now we have this array dex, and this UO8 value, right? So since it's called var UO8, we pretty much know exactly what that is, right? So let's make a section for variable declarations, and we'll put that var UO8 and the array dex in here. And the array dex, I don't know exactly what type we originally made it, but int32 should be big enough to hold everything. And unless we have a very specific size requirement, like a very specific reason we want to use a smaller type, we should probably stick to int32s to avoid problems with integer underflow and overflow. So we'll do int32 array dex, and then we'll also do var UO8, and those should be the only variables we actually need, I think. We actually have to call this somewhere now. Like, if we've gotten all of this correct, right, which I don't know if we have, but if we've gotten all this correct, this is the bitpack put. So let's go look for where we need to use this. So here's our put function, and we literally have a section called, we literally have a section called bitpacking, right? Because we kind of stole that section, right? This thing here. So what we can do is we can take all of this and cut and paste it, right? So we could we could even keep the defines, even though we're not using them, which might be kind of confusing. And for the put, we have the value to put. Let's just make sure that's correct. So in our notes, yeah, the tile value, right? Yeah, so right here, we could just nuke all of this, because we cut and pasted it already. And we could actually, we might want to keep this little, you know, C diagram, whatever. I think the diagram might be necessary, so that we know that, that we want to see, up in here, we want to see this main diagram. I might want to make a section here. I don't know. I'm gonna make a little thing here. C diagram. So the label, so we're gonna see this diagram label. So this is the diagram tag. This is the diagram label, and it's from, you know, this file, right? So just be a little bit more specific, I think, because the diagram has, like, we don't want to be looking over here. When we say C diagram P5D main, we don't mean this part of the diagram, right? We actually mean specifically this part, and so we've kind of made this big section, right? It's a lot of stuff for one diagram, so I feel like maybe we shouldn't have labeled it like that, but that's the way we labeled it, so we're kind of stuck with it that way. So we'll just keep this, like, extra tag here, right? And if we want to make a note of what that is, like, because we see that here. We can make a note of what that means, right? So, means PAINT5D offset bits. Tag exists in diagram in PAINT5D dot data. Right, so we can make a little note of what that's all about. Okay. So now, in our actual notes file, we have the put function we want to use. So we can just steal this, right? We just want to be able to steal it and call it. Now, the problem here is that we have to figure out what some of these need to be. So CPU picks is literally going to be this thing here, right? So we didn't delete that define, so you can make that all capital, and bam, we have it. The other thing is, it is a pointer, but it's a pointer in the sense that it's an array. So we don't have to take the address of this, because we already have, because this literally means an array, right? So if we took the address of it, we'd have a double pointer to U08, so we just want this, because it's already a pointer to U08, because it is an array of bytes. For the global component and whatnot, these are all non-pointer values, so what we really want to just do is make sure, hey, are all these values already represented? So we see that the global component, that is already calculated over here, right? And the, what about the tile value? So the tile value is an input, and the offset dex is also an input. So they're all accounted for here, so we're good there. We might want to, we still want to clean this up a bit, so we could keep the signature there if we can have enough room where we kind of do that. And let's take this notation here and say, so at div b4 means divisible by 4. Okay. So the reason it's divisible by 4 is because the component index is always pointing at the red channel of a RGBA cluster of 4 bytes. And therefore, if the component index is valid, it's always going to be divisible evenly by 4. So you start off with 0, right? 0, and then 1, 2, and 3. That's one whole byte. The next red index is going to be 4, right? And 4 is obviously divisible by 4, and then so on. With that said, though, we actually need to do some input checking there. So we have this kind of check here. So really what we have here is we have an input check section, right? So let's label that, right? And say that, input checks. Okay. Obviously, because we've indented a little bit, we have to either be more terse in our wording or reformat. I'm going to choose to be more terse because it's easier. Assertion is only valid if we are not unit testing. Sounds good to me. The original timestamp, that's good. Okay. So the next thing is, if the glowcom modulus 4 is not equal to 0. All right, let's put the 0 on the other side. Well, actually, it doesn't really matter, but now I put it over there. We have another error, right? Error, right, this should always be divisible by 4, right? So we can also make a note of that. So at vid id, right? Okay, so if we want to know why this is the case, we can look at this timestamp, but it's not divisible by 4. That's a problem. Okay. So now that we have some input checks, another thing we might want to do is make sure that this is non-null, because we don't want to get any seg faults. So, we'll say void pointer. Actually, we could actually be more specific than null now, because we're doing we've been like hard coding void pointers everywhere. But if we're gonna hard code it like that, really we should be even more specific, right? Because we can now say this. We can say that this is the exact type of void pointer, right? There's more than one void pointer, right? There's not more than one void pointer, but there's more than one type of null if you think about it, right? Because null is just like a 0 address, right? And so this would be a specific null for specifically this. So why don't we start to kind of like use our more specific null definitions if we're going to hard code them like this, right? So so if this is equal to right? Now, yeah, this is a cast, so this is giving us a little bit more information, because when we look at this comparison, we can be like, oh, CPU pix is this type, whereas if we do this, we know we're checking for null, but we don't know null of what kind of type, so we actually get more information if we do it this way. So I think we're going to start doing it this way, but old habits died hard, so we'll see how that goes. And just say, you know, null CPU picks. Okay. And at 1 hour, we're going to try to do 50 of, I don't know. Let's try to do our push-ups now, I think. Because actually at 9 we have to actually take a break to get food and take drugs and whatnot. So we should probably do that now. Yeah, so we got everything kind of fleshed out here and ready to go. Let's give this a run and see what crashes, right? Because we have it all stubbed out, but I'm sure we've made some stupid mistakes. So let's get it to where unknown type. Okay, so the U08 and the int32, we actually define those. So we have to define int32 over here. Let's put like a little checksum here to make sure that we know about how many defines we have for this section. Okay, and then down here, we have U08, and then we have the int32, and we can keep like a little checksum down here for, you know, we want to make sure that we undefine everything that was defined in this section. We need to undefine, right? So there we go. And give that a run, see what's next in terms of what we're missing here. So oslock is undeclared. So we have rdex and oslock is here. So let's put that, right? So so that should be a U08 value if you think about it. Right, its index should be, its index definitely should not be any bigger than 15. However, I don't think we need to worry too much about that. If we use a unsigned integer, that's going to make things harder. So let's just make it int32 oslock, and so right now we're not this offset location is in terms of bit packing. Okay, local. So it's a bit packing index. Oslock could mean like offset location. Let's make a note that lock is not equal to location. Right, it's not location. It's you know, it's not location, it's local. And I think that it would be good to keep track of that. So in our notes over here, in our notes file, let's make a note of this, because this is a kind of very generic sounding variable, and I definitely see where I could end up using this in other places accidentally and giving it a completely different meaning. So let's look at the whole code base and see what we can find in our files and see, are we using this anywhere else that we don't want to be using it? No, it's only in this file. Cool. So we can give it a formal definition now and just say, you know, oslock, if you spell it that way, then we're going to give a little check mark to say, hey, you spelled it correctly. Congratulations, right? If you type it like with a dash, if you type it with a dash like this, or like that, we'll correct you. And if you type it backwards, we're going to make you know that you did it backwards. So lock os. So say backwards, use os lock. And then os lock means, right? Lock. Okay. And if somebody types this, we'll say, we'll take this definition right here. Right, so it's going to specifically mean a bit packing index from now on in the code. And we're going to need another variable if we ever want it to mean anything else, even though it is a very generic name. So we could also say, you know, C paint5d.f, right? So we could also say, here's the file that it is in. And you can see that when we say C paint5d.f, well, what library, what code base am I talking about, right? That could be a problem. And that is kind of the reason for why when you talk about Scrum and you talk about context switching, this is why context switching is expensive, because if we only focus on one single code base, then we don't need to apply any extra context in our personal notes file about what we mean about paint5d.f. We already know it's in AAC 2020. If we start to work on multiple libraries at the same time, all of a sudden we need to add more context, which means we have to do more typing to differentiate the different contexts, right? So more context is going to slow things down. So we need to focus and say, this is the one code base that we really care about, that we're going to spend all of our time on. Okay, so var uo8, let's kind of do this as well. So var uo8, we already have that. Do we have what that means? So var uo8 means, yeah, so we already have that. That's good. How about the rdex means? So rdex means, how about just rdex? Doesn't look like we do. Okay, so we're going to add this as well. So what you're seeing with the U plus whatever over here, this is just a checkbox, a Unicode checkbox. So I have a little checkbox that shows me, hey, I did this correctly, kind of thing. So like, for example, since var uo8 already exists, if I type it correctly, and I do 2 commas, it surrounds it like that and does a little checkbox, so I know, hey, I did that correctly, and it recognizes it. So it's kind of like, instead of IntelliSense or code hinting, I kind of like code quiz myself. Okay, so if we do any of these versions, then we're going to do the correct spelling. And same thing with the other variable. So if we do it backwards, dex array, or dex array, or dex array, we'll say backwards, and use arr dex. Okay? And they also need a meaning for this, so what does arr dex mean? And if you type that, we'll recognize that that is the word you want a definition for, and then say what that definition is. So it's array in dex. Right? And then a more verbose definition in those quotes. So there we go. So we have the definitions. We can kind of put this back over on my other screen that you can't see. And keep on going here. So these are good as they are. We should probably give them if they can be negative, we might as well give them some trap values. Just because it's going to be easier to find problems if they are. But we already put this commentary here, so I'm kind of having trouble with initializing them to invalid values. So we'll just say, you know, right here we'll say set trav values. And this is a UO8, so it can't really be anything except for, you know, it needs to be something positive, and it needs to be within 0 to 255, so we'll just do that for sure. Okay. Is that good? Yeah, let's just give this a run. Let's try to get it compiling, and then once we have it compiling, old value, undeclared first. Okay, so old value equals, so when we cut and pasted this, we took some code. Okay, old value is actually something we need, and it should be a 32-bit integer, right? Because we're going to take old value. Well, hold on. Are we using old value for anything? This is a put, right? So we don't need old value for anything, do we? Or do we? Is that what we're doing wrong here? So var UO8, it contains the old value. We don't need to extract it here like we did in the other code. I can see this being nice to have, though. And in fact, in our code, we're actually using old val, right? We have it here, right? We're saying that, you know, right, we're already using it there. So if we want to implement that, then we're going to have to think about how old value kind of like factors into all this bit shifting here, right? And so I think for this, the way we're going to return it is we'll just return it as a, like, I do like the symmetry of our functions here, where they're kind of very symmetrical. So what we'll do is, we'll change this to a UO8, and this will be the old value. Right? I think that would be the best approach. And then and this old value here, previous, so this is the previous bit value stored. And for this, let's just, sure. And then we'll change the signature, right? We'll change the signature to a UO8. And then at the bottom, and we don't even have a return on this anyway, so we can do, at the bottom, we'll do return UO8. So, and that's not right either. That's, what am I doing here? Return old val. Return the value that was overwritten by val. Right. So we'll make a note of what we're returning here. And let's give that a run and see what else we have to do to kind of get this function kind of ready to go. Error, extract bit packing logic and write test. So where is that error coming from? Let's see where that is. So it looks like the only place it's coming from is here. Let's make a little face here. Let's make a little face. Make absolutely sure that that is where the code's coming from, and then we'll do our push-ups and whatnot because we have kind of stubbed that in correctly, and we're ready to stub in the next function. And then we have to write the test and whatnot, and the tests also have an error macro around them, so if we do like error like this, we should be able to find more errors than I thought. Yeah, so here's the bitpack get. Oh no, that's already... So where's the unit? Did we not use an error for the unit test? Let's look at what we did for the unit test. So we stubbed in the unit test. We did not write the unit test yet. So, so above here we should have, yeah, we should have, oh no. So let's, first of all, let's get rid of some of these. So here's the function. Do I not have breakpoints at these tests? Okay, so let's just look for this for a second and actually put breakpoints at these, right? So these functions, okay, so we're just doing ERR. That's why I couldn't find it. Let's also put breakpoints here, right? This actually needs our attention. And we're really not ready to go. We're really not ready until, we're not ready until the put test and the get test have been written. And then once those have been written, then we're kind of ready to debug and kind of figure out what's going on. But until these two are written, they're not ready. So I'm just going to be a little bit more redundant, put this error, put that error, right? Kind of like put more things that I can find it next time. Yeah, okay, cool. So we've stubbed in kind of this basic functionality that we want. We're not done yet, but today's kind of a slow day. I really don't feel like working. I'm just gonna do my push-ups and whatnot and try to get to 50 of everything. Let's look at my push-ups thing, which is probably old from yesterday here. Yeah, so we have not done 100 of each. We've done 0 of everything. And we're gonna try to like always do at least 100 push-ups, sit-ups, squats, and all that before we eat any food. That's gonna be the goal. So if we have not, if we haven't done our push-ups, then we don't get the food. And what I'm noticing here is that the drugs I'm on kind of like make me lethargic, and then it seems like right, the symptoms of lethargy and weight gain kind of go together, right? Because it makes you lethargic, so you get fat, right? And then once you're, and I think what's happening is once I get fat enough, it makes, I'm no longer lethargic, right? And then when I start working out and trying to burn off fat, once I start making progress, I turn lethargic again, and it's fucking horrible. So I'm gonna try to fight this and get back in shape and do stuff, right? So let's get a split timer here and do our exercises. Okay, so put on something interesting here. Let's hold on. So let's make a note of my, I'm gonna make a note of my music folder for a second here. So let's look at the bottom folder. So I just want to make a note of what the music folder is. 2021 music folder, something or other. I don't think these are things. I think that, let's make sure that these don't actually exist. Maybe I haven't reloaded my shortcuts. And yeah, I haven't reloaded my shortcuts in a long time. That's what's going on here. I'm going to take this and I'm going to go back up here. I'm going to paste it. We're going to find which ones of these are still unique. Only that one. Okay, yeah. So we'll take this, paste it down there, and we'll reload our shortcuts while we're doing this, because exercise is going to take a while. And we'll see how that goes. quick. No, not 500. Okay, we don't have much time before 9. That's when I need to do drugs and whatnot. So what we're going to do, I'm going to stop the stream and pick it up later. I'm going to just try to be like, when I don't feel like working, to at least get a little bit of stuff done in little tiny sessions. Monday is going to be the coffee day where we do like 16 hours worth of work. So hopefully we'll be more efficient then when we're all drugged up on coffee. Right now I need to reload my shortcuts, so I'm going to see that os lock. So that looks like it's already declared somewhere. We may have a problem because we did not... we didn't reload our... It's been a while since we reloaded our shortcuts, and so we actually have already declared some of the variables we wrote shortcuts for, which is very inefficient, very stupid of us. But oh well, we'll fix that. We'll fix up our shortcuts. We're going to try to reload them one more time, and once it's been a few minutes and we haven't had any collisions in our shortcut script, we're going to assume that everything has been properly reloaded and we'll be ready to start coding again with fresh documentation, like in our shortcuts. But yeah, so it took us about 20 minutes to do all those push-ups. So this is an hour and 30-minute stream, so, you know, 1/3 of the stream was basically exercising. But unfortunately, you might be like, man, I'm wasting time on exercise when I could be coding or whatnot. But your mind is kind of like a sharp knife, and if you have a knife and you keep on cutting stuff with it day by day, and you never resharpen that knife, initially you're going to be very quick and efficient, right? Because you don't have to take out that time to sharpen your knife. You're just going to cut some tomatoes, right? And you're just going to blaze away at cutting those tomatoes, but eventually you'll get slower and slower and slower and slower because your knife slowly dulls. And it's the same thing with your mind and exercise. If you don't get enough exercise, your mind slowly gets duller and duller. And at first you feel like you're being really efficient because, like, look at all this time you're not wasting doing all these other things, like, I don't know, eating healthy and getting exercise, right? You're just going to cram some energy drinks or whatever and just code. Yeah, you'll be efficient for a while, but eventually it'll start to take a toll on you, and your efficiency will drastically drop. So we're trying to maintain some type of consistent efficiency, even though our consistent efficiency is never going to be super blazingly fast. Okay, so what do we got? So Zelda tile map. Okay, hold on. So Zelda tile map. So, Link to the Past was 24 screens wide and 16 screens tall. Interesting. So I had like this OpenGL Zelda tile map thing that I was referencing for somebody on my stream earlier. And now I need to kind of like work on refining the shortcuts for that, which is what I am doing right now. It's actually... So I'm just making some notes of, I'm moving around some shortcuts right now. And yeah, so a lot of this is just kind of redundant stuff. I don't want to show you what's on my shortcut things because it might expose some sensitive information right now, so I can't show you what I'm working on. But I am just moving things around. Okay, so I'm ready to reload these one more time and see if there's any collisions, and then after a while, after it has loaded and seems to be working, then we're gonna be done for a bit. Maybe we'll come back, maybe we won't. We got a little bit of exercise. We did a little bit of code today. We want to be more efficient than this, but you know, sometimes we're just not feeling it. So we crawled ahead and wrote a little bit of code, and it's kind of like when I was doing push-ups, right? I could barely do any push-ups, and hold on. Right, I could barely do any push-ups at the end of that, but I try to do just a little bit more anyways, try to get those, pump out those few that were really hard to get out. And so I think when you're not feeling motivated and you're trying to get that little bit of code out, you're trying to build those brain muscles to where it's like, man, I don't feel like doing stuff, but let's just try to do a little bit of stuff anyways and try to build that resiliency into our brain, right? That might not be the best explanation, but I do think of the brain as sort of a muscle. So it can get burnt out, right? It can get burnt out, but then also it can get weak as well. So it's like, how do you know when you're putting too much strain on yourself? You know, like, what's the difference between burning yourself out and just building yourself up by giving yourself enough mental resistance to make it so that you can code and think for longer durations of time? And I don't know what the answer to that is. I wish I knew the answer, because that would solve a lot of problems if I knew what the answer was. And then I have to ask myself, do I even know the answer to that when it comes to physical exercise? And I don't know if I even know it then. So this looks like to me that it's reloading properly. So we're gonna get out of here. And then maybe we'll be back after we're done eating. But what we want to do is just the PAINT5D put and the PAINT5D get. We are trying to put these bit packing functions. We're trying to extract the bit packing logic from PAINT5D put and PAINT5D get into these separate functions so that we can test these functions, because we think that the reason our current tests are failing is because the bit packing logic is incorrect. That's what kind of some of the failures of some of the tests are kind of telling us. So we want to figure out a way to kind of test that logic in isolation. I would prefer not to have the bit packing functions as separate functions. I would rather have this logic inlined rather than putting it out into a separate function, for efficiency reasons as well as clarity of code reasons. Right, we're increasing the surface area of the code when we break things up into smaller functions. However, our code isn't working right now, and to make the code more testable, it is sometimes advisable to break things up into smaller functions. I don't like breaking things up into smaller functions, but at the end of the day, the number one priority is working code, right? So even if the style of the code isn't to my liking. Working code is the first priority, and we gotta do whatever we need to do to make it work. So we gotta go, because our timer is going off, so I will see you later.